In the constellation of Orion the Hunter, just under the three stars that make up its belt, is the majestic Orion Nebula. It draws our attention for its beauty and mystery. Ancient civilizations saw meaning as well, including the Maya in what is now southern Mexico and northern Central America. In their story of creation, three of the brightest stars in the Orion constellation represented a hearth. The nebula was the fire that warms it. At 1,500 light-years distance, it's one of the best-known examples of a star-forming nebula. A swirling cloud of gas and dust where stars begin their journey of life. Within it, Hubble astronomers discovered isolated pockets of gas called proplyds. These are protoplanetary disks that form around newborn stars in spinning mixtures of gas and dust. These disks are now thought to be planetary systems in the making. The brightest star in the trapezium star cluster affects the nearby disks by heating up the gas within them, causing them to shine brightly. The excited material produces many glowing cusps that face the bright star. Other interesting features enhance the look of these captivating objects, including jets and dramatic shock waves. They are formed when the stellar wind from the nearby massive star meets gas in the nebula. The interaction produces shapes like boomerangs or arrows. In one case, the shock wave makes the proplyd look like a space jellyfish. The powerful radiation that allows us to see these shapes also threatens their existence. Once heated up, the disks are more likely to dissipate and dissolve, destroying their potential to spawn planets. Some of the bright proplyds are doomed to be torn apart. The dimmer ones are the most likely to survive. Among those that do produce solar systems, Hubble has been documenting a wide diversity of planets. One of them, known as HD 189733b, is a huge gas giant similar to Jupiter. It lies extremely close to its star, as shown in this animation. Proximity to the star makes its climate exceptionally hot, with temperatures exceeding 1,000 degrees Celsius. A team of scientists used Hubble to observe it as it passed in front of its parent star. While backlit in this way, a planet's atmosphere imprints its signature on the starlight, allowing astronomers to decode what is happening on scales far too small to image directly. They expected to confirm that the upper layers of the planet's atmosphere are boiling off under the intense starlight. Hubble's first observations showed no trace of this. Just before it could take a second look, the Swift satellite detected a huge flare coming from the surface of the star with powerful atmosphere-frying X-rays. When the planet slid into view a few hours later, the changes were startling. Where astronomers had seen a slumbering planet before, now they saw an atmosphere furiously boiling away. In a dramatic plume of gas, the planet was losing at least 1,000 tons of gas from its atmosphere every second. There's no life on a planet that orbits so close to its parent star. Such planets, however, are allowing Hubble astronomers to hone their search for Earth-like planets further out. When the planet moves between the star and Earth, Hubble has been able to capture a small fraction of starlight passing through the planet's atmosphere. Astronomers are looking for a hydrogen-carbon compound called methane. On Earth, it's produced by a combination of natural and man-made sources, including fossil fuel production and livestock. On this hot Jupiter, methane is probably produced by a complex chemical process in its atmosphere. Astronomers plan to use data to identify prebiotic molecules in the atmospheres of planets in the habitable zones around other stars, where more moderate temperatures would allow liquid water to flow. The new measurements are an important step toward the ultimate goal of identifying the conditions, such as temperature, pressure, winds, clouds, and chemistry, on planets where life could exist. Astronomers have detected a wide range of planets around other stars by looking for clues, like the wobbling motion of a star as a planet orbits it, or a star getting dimmer as a planet passes in front of it. Hubble was able to capture for the first time a direct image of a planet. Visible from the southern hemisphere, Fomalhaut is relatively close, at around 25 light-years away. It is 15 times brighter than the Sun and much hotter. This star is blazing through its hydrogen fuel supply at such a furious rate that it will burn out in only 1 billion years, 10% of the lifespan of our star. Its most interesting feature may be a large disk of dust and gas that surrounds it. This strange ring is not exactly centered on the star. Astronomers suspect that the gravity of another body, perhaps a planet, is pulling it out of shape. The suspected planet is a dim speck. To see it, astronomers used an instrument called a coronagraph to block the star's light. Then they gathered a host of clues to find out what it's like. For one, the shape of the disk hints that the planet is at most 3 times the mass of Jupiter. For another, the planet is much brighter than expected for an object of its size. That means it could have an enormous ring system that reflects starlight in all directions. One day, the material in these rings may even coalesce to form moons. Hubble is part of a larger quest to discover and understand solar systems, including our own. Among the highlights, astronomers have used Hubble to track the changing climate of cloudy Venus. Dust storms that sweep across the planet Mars. The aftermath of comet Shoemaker-Levy's collision with Jupiter. Saturn's stunning rings and moons. Uranus's rings. And Neptune's intense, turbulent atmosphere. In our solar system, few Hubble images compare to its views of Saturn and the fluttering aurorae that light up its poles. Scientists created a movie from data collected over several days during January and March 2009, when the rings appeared edge-on and both poles were visible to us. The Sun emits a wind of particles that reaches all parts of the solar system. When this electrically charged stream gets close to a planet with a magnetic field, like Saturn or the Earth, the field traps these particles. The magnetic field is stronger at the poles, so the particles tend to concentrate there, where they interact with atoms in the upper layers of the atmosphere. That's what creates the familiar nighttime glow we know as the northern and southern lights. Saturn's auroras are not only charming features, but they might teach us something about our own planet and its magnetic field. Beyond Saturn's dancing lights, or the sudden explosion of a star, the universe appears unmoving against the ponderous march of cosmic time.